Recently, the two Pakistani authors Amir Iqbal and Dr. Faisal Shahzad from Chemical Physics departments contributed their part in the development of a new electromagnetic interference semi-shielding material that is supposed to be having a great potential for being inducted in future wireless electronic devices and components. Their research has been recently published in one of the highly cited and rated journal named as Science with current impact factor of 41.845 in 2019. The journal bears an exceptionally high impact factor one can dream of. Amir Iqbal is PhD student at Korea Institute of Science and Technology in Department, Center for Materials Architecture, under University of Science and Technology, South Korea. Dr. Faisal Shahzad has done his PhD in nanomaterials science and engineering from KIST, and is serving as assistant professor in Pakistan Institute of Engineering and Applied Sciences abbreviated as PIAS, Islamabad, in the Department of Metallurgy and Materials Engineering. The research interests of both authors cover advanced 2D materials, muxins and graphene, for electromagnetic interference, EMI, shielding and biosensing applications. As we know that more and more wireless electronic devices are becoming the part of our ecosystem, bringing the convenience for us, however making our neighborhood polluted with electromagnetic noise. This ME noise interferes with other electrical components, such as antennas and circuitry. It diminishes electrical performance, and can slow data exchange rates and can even interrupt the function of devices. To counter such noise and other problems, most of the so far discovered shielding materials simply prevent the penetration of the electromagnetic waves by reflecting it away. Electronics designers and engineers tend to use shielding materials to contain and deflect ME in devices, either by covering the entire circuit board with a copper gauge, or, more recently by wrapping individual components in foil shielding. But both of these strategies add bulk and weight to the devices. While the current discovery is quite effective not only for protecting components, but also alleviating the overall problem of electromagnetic interference propagation in the environment. The material used in the discovery, called titanium carbonitride, is part of a family of two-dimensional materials, called muxins, that was first produced at Drexel University in 2011. Researchers have revealed that muxin materials are much thinner and lighter than copper, and can be quite effective at ME shielding. This material have a number of exceptional properties, including impressive strength, high electrical conductivity and molecular filtration abilities. Titanium carbonitride's exceptional trait is that it can block and absorb electromagnetic interference more effectively than any known material, including the metal foils currently used in most electronic devices. Through a series of tests, the group made a startling discovery. Namely, that a film of the titanium carbonitride material, many times thinner than the thickness of a strand of human hair, could actually block ME interference about 3-5 times more effectively than a similar thickness of copper foil, which is typically used in electronic devices. Perhaps more significant than the team's discovery of the material's shielding prowess is their new understanding of the way the discovered material works. This also means that titanium carbonitride could be used to individually coat components inside a device to contain their ME even while they are being placed closely together. Companies like Apple have been trying this containment strategy for several years, but with success limited by the thickness of the copper foil. As devices designers strive to make them ubiquitous by making them smaller, less noticeable and more integrated, this strategy is likely to become the new norm. In addition to Amir Iqbal and Dr. Faisal Shahzad, many other researchers from Korea Institute of Science and Technology contributed to this research. Their findings, reported in Science, indicate that a muxin called titanium carbide showed the potential to be as effective as the industry standard materials at the time, and it could be easily applied as a coating. This research has become one of the most impactful discoveries in the field and inspired other researchers to look at other materials for ME shielding. To the best of our knowledge, this discovery breaks all the barriers that existed in the electromagnetic shielding field. It not only reveals a shielding material that works better than copper, but it also shows an exciting, new physics emerging, as we see discrete two-dimensional materials interact with electromagnetic radiation in a different way than bulk metals. For this achievement, we would like to congratulate the authors for representing Pakistan in industrial research and bringing forth some good work on the part of nation. Pakistan desperately needs such linkages between industry and academia, so that the research students may perform a productive research for the country.